In this and the next lectures, we want to pull stock price data for the Dow Jones Index and for the 30 constituents from a web API. But before we can do this, we have to get the 30 constituents and their ticker symbols. So ticker symbols are kind of an abbreviation and a clear identifier for a stock. And actually we need that symbols to pull the data from the web API. And either we know the constituents of the Dow Jones Index inside out, or we have to get some help. And in many cases, Wikipedia can help. So let's go to Wikipedia, and this is the article on the Dow Jones Industrial Average. So let's scroll down here. And here we can see a table with the company name, the exchange, and also the ticker symbol here. So for instance, the symbol for Apple is AAPL. And we have some more information on the industry, the date added to the index, some further notes, and the weights of the constituents in the index. And actually it would be great to load this table into pandas, and there's a simple way to do it. So we can actually use the direct pandas method, pd.readhtml. And first of all, let's import pandas as pd. And now let's have a look inside here. So the readHTML method reads HTML tables into a list of data frame objects. So in other words, it loads tables from the web into pandas. And we simply have to pass actually here the URL. So let's copy it here and let's paste it here to pd.readHTML. Now let's simply run the cell here. And here we have a list with all tables or data frames that we can find in the website here. So this is obviously the first table, then this is the second table that we are actually interested in. So let's actually index here the list for maybe the very first element. And this isn't the table that we are interested in, so let's have a look at the second table. And that's actually our table here. So we save the table in the variable const for constituents. And actually we can drop some columns that we do not need. So for instance, the nodes or the index weightings. And we only select the first 5 columns. And at a very first glance, we have an issue here with the column label date added. So a white space in a column header or column label is actually not a good idea. And therefore, we should rename this column label to date added with an underscore. And also it might make sense to convert the data here in the column date added to date time. And we can actually do this with pd.toDateTime. And let's have a final look here with the info method. So we have no missing values. We have text data in company, exchange, symbol, and industry, and date time in the column date added. So this is the constituents data frame, but the data frame isn't clean. And we will see this in the next lecture. So hope to see you there. Bye. All right, we have still the const data frame here. And it seems like we are only one step away from extracting the ticker symbols from the column symbol. So for instance, MMM or AXP. However, we have one problem. And first of all, let's go here into this symbol column. And let's get one element here. So for instance, the first element. And here we have an additional \x, a, and 0, and the same we have also here for the second element and so on. And the problem is that the strings are originally coming from HTML code. And first of all, we need to encode and normalize these Unicode strings into a normal form. And we can actually do this with the module Unicode data. But first of all, let's again have a look here with the info method. And here we simply cannot see that we have a problem here with the Unicode strings. So we have here object like for any other text column. And actually, to be honest, Unicode isn't really the most exciting topic. So I will keep it short here. And if you want to know more, then Wikipedia can help with some more details. So for instance, here on the article on Unicode equivalence. So that's probably not the most exciting stuff that you can find on Wikipedia, but now let's go back here. And let's import the Unicode data. And now we have to encode or normalize each and every element in the symbol column. So first of all, we use here the apply method and create a lambda function. And actually we pass each and every element to the method Unicode data.normalize. And let's go here inside. And this returns the normal form for the Unicode string, and there exists actually 4 different normal forms: NFC, NFKC, NFD, and NFKD. And we will require here NFKD, which stands for Normalization Form Compatibility Decomposition. And you can also find here some more information on Wikipedia on the normal forms. Now let's normalize all elements in the symbol column. And let's go here inside one element. And now this looks pretty good. And actually now we can override the symbol column. And let's again have a look. So now we have normalized the strings. And now the plan is to extract the ticker symbol AXP from the string here. So here we can see that this is listed on the New York Stock Exchange. And actually we can split the strings with str.split. And actually we want to split the strings at the colon white space. So let's have a look what happens here. So we are splitting the strings at colon white space and save the fragments in a list. So on the left hand side we have NICE, and on the right hand side we have the ticker symbols. And actually we want to extract here the second element in the lists, and we can do this for each and every element, again with the apply method. And we use here a simple lambda function, and for each and every element, or for each and every list, we select the last element. So at index position -1, so that's the ticker symbol. And now we have here the symbols MMM, AXP, Apple, and so on. And now let's create the additional column ticker. Now here we have the ticker symbols. And actually for the next lectures, we can convert the panda series or the columns here to list with the method toList. And we save the list in the variable ticker list. And finally, we also export and save the data frame constituents in a CSV file, constituents.csv. So we will need this file in later sections or projects. And with this, we have reached the end of this lecture, and see you also in the next video. Bye. Now we have the ticker symbols, and in the next step, the plan is to get historical price data for all 30 companies and also for the Dow Jones Index. And we can get those data from Yahoo Finance. We are here on the website, and we can search, for instance, for Microsoft, and the ticker symbol is MSFT. So here we have many information on the Microsoft stock, and we can actually get historical data here, and then we can download here a CSV or Excel file for a specific time period. And that's actually the hands-on solution and works for one stock, but this is of course not scalable. And also here we should use the web API and pull the data from the web API. So use here some HTTP requests. And sometimes there's a so-called wrapper package available that makes our life much easier. So we do not have to reinvent the wheel and develop the code with Python and requests. And actually the good news is that for Yahoo Finance there exists the wrapper package yfinance. And actually yfinance is not part of the Anaconda installation. So first of all we have to download and install yfinance. And we can do this with a very simple command that we have to enter in the Anaconda prompt. or alternatively, if you are working with a Mac in a terminal window. So I'm going to open here anaconda prompt. Here it is. And with the following command, we can download and install yfinance. So it's pip install yfinance. And now let's press the enter key. And here we can see that we have successfully installed the following package, yfinance version 0.154. And with this, we are prepared to pull data from Yahoo Finance. And that's exactly what we are going to do in the next lecture. So hope to see you there. Bye. All right, in this lecture, we are going to pull historical price data for the Dow Jones Index and its 30 constituents from Yahoo Finance. And we have to import pandas and also yfinance as YF. And then we can actually download historical prices from Yahoo Finance with the method download. And the most important parameter is here tickers. And here we can either pass one ticker for one stock or one index or a list of tickers. And let's start with the Dow Jones Industrial Average Index. And the ticker symbol is the following. So typically indexes are starting with a circumflex, and then we have Dow Jones Industrial Average Index. So let's have a look here. And by default, we get the full history. So starting with the first day where price data is available. In this case, it's 1985. And actually, we get here daily open prices, high prices, low prices, and close prices. And also adjusted close prices and some information on the trading volume. So for our purposes, we are only interested in the period from 2007 until end of March 2020. And actually there are two additional parameters, the start and the end parameter. And here we can define the start and the end date. And actually then we save the resulting data frame with the prices in the variable Dow Jones index. And let's have a look here. So we're starting at the 3rd of January 2007 until the 30th of March 2020. Now let's also get some meta information with the info method. So in total we have over 3,000 timestamps and 6 columns. And actually it's worth mentioning that here in the index we have a daytime index with over 3,000 entries in that period here. Now let's save and export the dataset in a CSV file, and of course we can do this with 2CSV. And now let's go on with the 30 constituents, and we have still saved the 30 tickers in the list, the ticker list. And now instead of passing only one ticker, we can pass the full ticker list to the parameter tickers. And again, we have the start date and the end date. So let's save the resulting data frame in prices. And let's have a look at prices. And here we have a multi-index in the columns with 2 levels. And as outer level, we have actually adjusted close, close, open, high, and so on. And as inner index level, we have the 30 tickers. And we can also check this here with the info method. So in total, we have 180 columns. And actually, for our purposes, we are only interested in the daily close prices. So we don't need daily open, high, or low prices. So it's sufficient to have the daily close prices at the end of the day or the end of the trading day. And therefore, we select all rows and only the outer index level close, and we actually override prices. So now we have the daily close prices for the 30 constituents from 2007 until 2020. And finally, we can also again have a look here with the info method. And here we can see that we have one constituent where we only have the 260 most recent prices. So here we have kind of a new listing. And also for the ticker V, we have some missing values here. And actually, we are going to work with this data set here and the prices in one of the next projects. So let's export and save the data set in a CSV file, constituent prices.csv. And with this, we have reached the end of this project, and see you also in the next ones. Bye.